Right. Now we jump to theorem number 7, right? Now we jump to theorem number 7 and its converse. Normally, I would call this theorem an axiom, yeah? But we can just call it theorem number 7. It's still fine. Or you can also refer to it as an axiom. Now, how does the theorem number 7 works? A tangent, you know what is a tangent? I'm not going to explain that anymore. A tangent to a circle is perpendicular to the radius at a point of contact. We have tangent AC, we have radius OB. So this tangent, it will act perpendicular to this radius. What is the radius? Line from center to the circumference. What is tangent? A line that touches circle only at one point, which is point B. So tangent and radius, they meet at point B. If you have a circle that looks like this, that means remember, you have a circle, I'll try. You have a tangent. Let's assume, hey guys, let's assume it touches, even though it doesn't touch. I'm trying here. Let me, yeah, we'll just assume that it touches. I'm trying to make a tangent. It's gonna be hard for me. And therefore, we have the center and a line from center to the tangent to that point of contact, which is point B. A, C, and center O. What does this mean? What does this mean? If you have something that looks like this, that means OB, which is this line, it will act perpendicular to AC. That means here, we're going to have perpendicular. We're going to have 90 degrees. Why do we say OB is perpendicular to AC? So if OB is perpendicular to AC, that means I'll call this angle B1 and then this one angle B2, just like here. I will say angle B1, or you can say angle B2 is equals to 90 degrees. Because it's perpendicular, we know it's 90 when things are perpendicular. But then, what's the reason? Why do we say B1 is equals to 90 degrees or B2 is equals to 90 degrees? We're going to say, this is the reason that we use. We're going to say tangent for tan is perpendicular to radius for rad. This is the reason that we always going to use when giving this statement, that tangent is perpendicular to radius. That's why we, in fact, yes, tangent is perpendicular to radius. That's why we say angle B1 is equals to 90 degrees. Simple, just like that. And then what is the converse? You know, sometimes they will give you a circle like this, and they will give you a line like this. You see line AC. You see line AC. Line AC is not a tangent. It is not. Why? Because you are not told that it is a tangent. You are not told that it is a tangent. Unless if we prove that AC it is a tangent. Unless if we prove that AC doesn't, then it isn't. But for now, it is not a tangent. You don't assume. Even though by just looking at it, it looks like a tangent. But what if it touches 2 points? It's just that you don't see, and then therefore it's a secant. You understand what I'm saying? So that's why in Euclidean geometry, you don't assume unless if you are told. You don't assume unless if you proven it to be that what you think it is. Even a square, you see like this. What is this? If I ask you, all of you, if I were to ask you, all of you, you're going to say this is a square. But it is not. Did I tell you that is this a square? I just drew a figure and I say, what is this figure? You say it's a square. Who said it's a square? It is, even though it looks like a square, it's not. So because the square, we know all of the sides are equal, but what if this side is greater than this side a little bit? Maybe this is 10 centimeter. What if this is 10,1 centimeter? You're still gonna say this is a square. It's not. Unless if we prove using the properties of square that this is a square. That's why we need to learn the properties. You understand what I'm saying? So we need to prove that in exam, I can even say we have a point there, which is point B. We can just say it's B here, ABC. Prove that ABC is the tangent, or prove that AC is the tangent, does not matter. And then let's say you are given a center, you are given a line. Ne? Remember there, we had to prove that here it's 90 degrees. We had to prove that OB is perpendicular. Here they tell you that, that uh, they tell you that OB is 90 degrees. If they tell you that OB, it is perpendicular to AC, or they tell you that B1 is 90 degrees, however they tell you, say maybe they tell you that B1 is equals to 90 degrees, angle B1 is equals to 90 degrees, or they say OB is perpendicular to AC. If they tell you this, what does that mean? Excuse, that means we can simply say AC, or you can say ABC, does not matter. You can even say you can say AC or AB. ABC is a tangent because you use the theorem, you use the converse theorem of tangent. So remember, the theorem, they're going to give you something like that. Simple, they give you something like this. And you, by using the theorem, you say this is 90 degrees. The converse, you're going to be given something like that, but here they're going to tell you it's 90 degrees. Therefore, you're going to say this line is a tangent. That's the converse. So now we jump to theorem number 8 and theorem number 9. So theorem number 8, it says to us, if, look, this is the diagram, right? That goes with theorem number 8. You have the center. Look at this. What does AB look like? What does AB look like to you? It looks like a tangent, right? What does AC, line AC, looks like to you? It looks like a tangent. You see, it's like we have two tangents in one circle. And then it says if two tangents, and this one doesn't appear a lot, man, but let's do it. If two tangents are drawn from the same point, this is the same point they're talking about, which is point A, and these two tangents are drawn from the same point. Another tangent here it is, they are drawn from this point, which is point A. If two tangents are drawn from the same point outside of the circle, which is here, then what does that mean? They are equal in length. Simple. But remember, we know from axiom 7, from theorem number 7, we know that this is theorem number 7 in play again. Why do we see that? Why do we say B1 is 90 degrees? We have just spoke about it. Radius perpendicular to tangent, because you are told that AB is a tangent, and this is a tangent, this is a tangent. A line from center to, that means it's 90 degrees. So already, so we apply theorem number 7 automatically. But the thing about this theorem, which is theorem number 8, it says to us, line tangents from the same point, tangents, tangent 1, tangent 2, tangents from the same point, tangents that are drawn from the same point, they're equal in length. So that means AB, which is from there to there, will be equals to AC, which is from there to there. Done. We are done. What will be the converse of this? The converse will be if you are told that BA is equals to BA is equals to CA, then that means BA and CA, they are tangents. Agree here, we are told they are tangents. If they are tangents, this side will be equals to that side. But if they tell us that this side is equal to that side, that means those sides are tangents. It's just the converse, it's the reverse. Okay, that's how theorem 8 actually works. It's simple, but they don't like asking much of the questions on this theorem one. But let's just know it for safety purposes. They don't even asking both of this. Therefore, let's jump to theorem number 9. Theorem number 9, which is the last theorem. I love this one. Hey, this one. Hey. I love this one. Tan-Cod theorem. It's called Tan-Cod theorem. Tan-Cod theorem. It's called the Tan-Cod theorem. Tangent with chords. Look at the triangles are made up. Well, this triangle is made up of chords. Chord. So they say to us the angle between a tangent. Let's talk about one angle. Let's talk about B1. This is the angle. It's between where? The angle between the tangent to a circle and a chord. Look at the angle they are talking about. Let's talk about B1. This is a tangent, right? Look, ABC, it is a tangent. You're going to be told that ABC is a tangent. EP, it's a chord. So this angle, it's between the tangent and the chord. What about it? The angle between a tangent to a chord drawn from the point of contact is equals to, this angle is equals to what? B1 is equals to an angle in the alternating segment. This is the segment and this is the segment. These are the alternating segments. So that means it will be equal, not this segment. We are not talking about this. We're talking about the alternating segment. This segment alternates with this segment. So that's why we call this theorem tan-chord theorem, because it's all about the tangent and the chord. So that means angle B1 will be equals to angle D, né? Which is this angle. It's true if AB, ABC is a tangent. Well, if they tell you that ABC is a tangent, you can talk that. If they tell you that ABC, if they don't tell you that ABC is a tangent, how can you say this is a tan-chord? Where is tan? Where is tangent here? You need to be told that ABC is a tangent. But if you're not told, therefore you're going to be forced to prove it that ABC is a tangent. Now, guys, so that means in this case, we can talk about that. And therefore, look at B2. B2 is the angle between where? Between the tangent and the chord. And then we have the alternating segments, which is this segment, and that angle will be equals to that. So that means angle B2 will be equals to angle E. Simple as that. If it's 40, there will be 40. If it's 60, there will be 60. Simple. And then sometimes your diagram can be presented in this way. It does not matter. Oh, again, be careful. Ne? To say this is a tan-chord theorem, make sure that the vertices, make sure that you have the chords. In fact, it's a chord. If it's a triangle, make sure that the vertices are at the circumference, because this is a chord, obvious. This is also a chord. Make sure that the vertex of your triangles are at the circumference. Let's have a look at this one. The vertex is at the circumference. Vertex at the circumference. Vertex at the corner, né? At the corner of the triangles are at the circumference. All of them. Are we safe to talk about the tan-chord theorem? They tell us ABC, it's a tan-chord, it's a tangent. Or if that's the case, that means the angle between the tangent and the chord will be equals to what? Which is angle B1 will be equals to what? Will be equals to angle D. Why am I saying B1 is equals to angle D? It's because it is the opposite angle with the alternating segment. This is the segment, and this is also the segment. And then we are done. But we're still going to learn on how to prove these theorems. So do we all understand how these theorems work?